Brossat from EDF in France.
So good morning, good afternoon, ladies and gentlemen, and welcome to my presentation. Thanks for the organizer for your invitation. My name is Xavier Brossat. I work at EDF and EDF Research and Development, and I work in Department Osiris. I will speak later about this department. And I am in charge of forecasting for EDF, operational forecasting. We have to forecast the consumption for the following day, for the week, and I am in charge too to the prospective research and about forecasting, because as we can see this morning, there is a lot of change in the electrical system, and I will speak of that from the point of view of the forecast demand. I will speak about wind forecast. I will speak about energy market, but it will be not so fully that than in the presentation of this morning, particularly the presentation of Mr. Smith, which was very full. But I will look only focus on the demand. For Electricité de France, we have. We were able to forecast the consumption with a really good accuracy of 1.5%. And currently, there is, due to the new competitive environment, the electrical curve has become more and more complex to forecast, and we have to search new methods. Briefly, my department is Department Osiris. We are in charge of the energy management. The energy management is what we are able to supply, and with what we are able to do about the demand size uncertainties. And finally, we have to do that the give equals the demand. So we have to take investment decision, system flexibility, fuel supplies. Nuclear maintenance is a very important point, because in France, the part of the nuclear power plant is from almost 80%. So really a problem to maintenance this nuclear power plant. And we have to take in account the problem of carbon. And we have to be able to do the generation plan for the following day, because in France, there is, from 5 or 6 years, there is a market, but the competitors of EDF are very low currently, and EDF have to assume the security of the electrical system, the national grid. But it's very strange, because we have to make benefits, and we have to assure the security. And for the demand size, we have to be able to forecast the long-term forecast, the medium-term forecast. And now for the medium-term forecast, is in this case, there is all the problem with evolving of the use, with capacity market, with evolving of the renewable, because in France currently the part of the renewable is relatively low. I think it's the same quantity than in England. And we have to do load forecast, and we are able to do a forecast for the following day, and you are able to do forecast during the day. My department is in charge of this management of market risk. We have to do financial mathematics, optimization, risk management. In this department, there are 100 people that are working on these different topics. Donc, optimisation financial market, optimisation, portfolio management, and we have to do statistic optimization, and finally I will speak today from load forecasting, and we are load forecasting and uncertainty forecasting. So I will give you some characteristics of electrical consumption in France. Secondly, I will speak of briefly of the operational model and its limits. And my purpose is to give you an overview about methods we tried those last years for forecasting electrical consumption, and especially of the future work, because in this context, and I think is for everybody in this week, is to be able to find a mathematical solution for the new problems. And when I heard this morning Mr. Smith, all the problem was given, but the solution, the mathematical solution, not very evident. And I think we have to coordinate a lot of topics, not only statistic, but mathematics, but perhaps operational research and other mathematic topics. And it's very important to be able to solve together this problem. The characteristics of electrical consumption in France, so it's not very original. In each country, I suppose that the consumption is the same. We have various seasonal components, high dependency on climate, and we have some periodicity, the week, the Saturday, Sunday, and Monday, and each day of the week. And we are during the daily cycle. So it's important to understand to see the daily cycle, because due to the new behavior of the customers, the evolving of the use, for example, if we recharge the electrical car battery, the load curve will become like this, and perhaps we have to study, to simulate how is the behavior of the consumer on the peak of electricity. And in France, perhaps we have a very important particularity. It's the part of the importance of the climate, because in winter, the peak of consumption can reach 100 gigawatts, and the part of electrical heating is a quarter of this part. It's very important, and we have to identify very correctly the dependency between climate and consumption. So as you can see, there is some cycle of electricity consumption. It's very regular at this moment. We have some difficult period to forecast: Christmas, May, August. There is a lot of bank holidays, and it's very difficult to forecast. And we have not to believe that it's no problem during the bank holidays, because the consumption is lower than usually, but it's very important because during the bank holidays, the provider maintains the electrical power point, but even the consumption is low, it's important to forecast with a good accuracy. I spoke about the influence of the temperature. As you can see, there is a cold week. Yes, the temperature is very cold. As you can see, the temperature is under 0 degree, and the consumption, when the temperature is very low, the consumption is very high. So we have a lot of problem, because it's possible to forecast. We have a transfer function between the temperature, evolution of the temperature and the consumption. But during the period where the temperature is very cold, we have not enough points to identify correctly the model, and really a problem, and we have to use some adaptive methods. The importance of bank holidays, special day and events. I think in France we have a lot with bank holiday and the bridge. We can reach 1 month of particular. We have the problem of economic crisis as a very important impact. As you can see, the economic crisis at the end of 2009, it introduced a lot of abrupt variation on the load curve. Yes, we have a good quality of forecast. We study this problem during 25 years, and we improve a lot of mathematical method, regression method, ARIMA model, Kalman model, but it always on the aggregate load curve. And we have a current accuracy of 1.2% for the forecast of the following day. Donc why more? Why we have to continue to study? Because we have some very difficult period, winter, with fast change in the temperature. It's very important because if the night is warm and the day is cold, the difference between the temperature induce often error in the forecast. Due to the new competitive environment, it's relatively new in France, and we have not a lot of information about customers, the competitors, and was said this morning, the rules are changing every month, and it's very difficult for the rules. Who can buy electricity to EDF? We can sell electricity. What is the market? It's very, very difficult to be able to have a robust behavior. The customer are able to live and join the company. It's very important because for us it induces a non-stationary signal. Now we have to do local forecast because for the distributor it's very important to be able to do forecast for economic reasons, sure, but essentially for taking into account the problem of renewable of the network, because when available and there is a problem with reactive power and more intensity is very important, and sometimes the needs of the distributor are not the same needs as the provider. There is a problem of global optimization versus local optimization. And we have taking the evolving of the use. It's very important. I will speak a little after that. We have to evaluate the certainty and provide forecast interval. From 20 years, 30 years, the forecast that we made is a determinist forecast. And I heard very attentively Pierre Pinson this morning, because the problem to be able to give a probabilistic forecast is not very easy. We have some solution. I will speak of the solution, but we are not very sure to validate this forecast interval. And so we have institutional mechanism, data acquisition. Another problem which is relatively important is the problem of data. In France, there is a big difference between the provider, the RTE, the regulator of the network, and the distributor. It's very, very difficult. We have we can have some data. We are obliged to simulate a lot of data. We have difficulty with measuring individual consumption. The smart meters are it's very long to install smart meter. There is a lot of problem of price, problem of the network is very old. The meters, current meters are very old. We have short past time series. Sure, when we have a national consumption from 40, 50 years, but the consumption of local time series, we have only short data. It's very difficult to use. But different portfolio, different sampling. Some data are sampled at each hour, some data are sampled 10 minutes. We have to mix all these problems. A new electricity meter, big data flow, and the problem of as I said, the renewables network. One of the first problems we have to solve is variation of the portfolio. This curve is relatively old, but for confidential reasons, I cannot give you the real parts of customers they leave EDF. But for us, it's important to. We have some problem like the problem of commercially contracted interruption. I don't know the term exactly in English, but that is a slide that PG&E, the big company of San Francisco in California gave me about the time variable electric price. I don't know if it exists in Europe, but in USA we have the real-time pricing. So it's very difficult even to use this time of use pricing. To be able to identify real-time pricing is very difficult, is very important. But in California, it allows to limit the point of the peak of cooling. It's very important, and they do that because environmental concern in California are very strong. So we have to do local forecast and national forecast, but we have the distribution network. We have to do a lot of forecast. So it's difficult because to do the national forecast, we have some data, and the local forecast, we have short data. It's difficult sometimes to forecast this kind of time series. So another the network. Linky, we have to measure to 35 million of smart meters, and it will be intelligent in France, and more important is customer behavior and news. A lot of people write a lot of things about this topic. We have a multimedia network. Now, currently, there is a multimedia network, and the domotic network is growing. I speak for French, perhaps in other company, I don't know exactly what it is, but some problem for the consumption. For example, when we have to forecast at middle term the consumption, we have to take in account the hot water heater. The hot water heater, the law in France, I think is the same thing in Europe. We cannot install Joule hot water heater in a new building. We try to replace this hot water heater by thermodynamic heater or individual solar heater. It's very important, and we think that for EDF is a very important part to reduce the consumption, and particularly at the peak of consumption. We will do a lot of simulation about this, and cannot show you now. Always for confidential data. There is a big question is recharge of individual car. It could be a very important part to manage the energy, and the behavior of the consumer. Perhaps is the consumer sensitive to the box, or for example, I think that in some company in USA, the consumer don't care of the box, of the control of the energy, and I think a big company like Google stops the program of box because the benefit is not very enough important. It can be a discussion. And the big problem is the problem of the stockage, store the energy. It's not very, I think there is not currently a very good technical solution. In France, we encourage development of the heating pump, because the part of as I told, the part of electrical heating is too important. And general problem is the problem of the efficiency energy. The consumption for middle term forecast with energy efficiency within incremental energy efficiency. Another problem is, as everybody knows here, the problem of the injection of renewable on the network. There is a demand, the generation, and suddenly there is a peak of wind farm production. And it's difficult for the load curve as a consequence of the network. So I will speak briefly of the operational model and its limit. It's not too difficult to understand me. No? You can because English is terrific for me. So with the operational model, the model works well every day. We consider that the consumption is a part of the consumption independent of the heating, a part independent of the heating, plus any rates consequence and noise. So we consider that the hourly consumption is depend of the day of the year and the load shape depending of the day of the type of day, and we introduce a seasonality, the seasonality in winter during the day by Fourier series. And the part of the weather depends on the temperature. So we consider that we don't use temperature given by Météo France. We use the temperature felt inside buildings as explanatory variable because we think that the consumer is not the consumer outside of the building, is considered as the temperature felt by the consumer. Oh, we have a transfer function, we have a lot of parameters to fit, and we have, of course, a problem between the robustness of the parameters and the adaptativity of the parameters. It's always all the debate in this problem. And as we can see, there is the gradient of the temperature. The temperature is high when the consumption is the gradient. The temperature is when the temperature is high, the consumption is low, and when the temperature is cold, the consumption is. So you can see the result in terms of RMSE are relatively good. But it depends of some situations, some periods can be more difficult. So we have a sophisticated and efficient model, but we have to fit a lot of parameters. We have problem for using asymptotic parameters and bootstrap approach. With the bootstrap approach, we have too much temporal dependency. It's not very efficient to do that. So from 5 years, you study simplified methods such as generalized additive model. And my colleague Yannick Good will talk you in few minutes about generalized additive model more precisely in terms of mathematical. Now I will just show you a lot of some methods we use. So we have to think to the problem of adaptivity. It's when the consumption was very robust in France, was no change in consumption. It's relatively easy to use a robust model, but now you have to solve the problem of adaptivity, the problem of move of customer, the problem of parsimony. We have a lot of, for example, we have 2,000 forecasts to do on the distribution network, and it's very important to be able to have a relatively parsimony model. We are able to estimate very quickly. We have the problem of disaggregate. We have to put in relation the individual data and aggregate data. There are some correlation. We have a lot of model which take in account the individual part and the aggregate part. It's very important to introduce a priori knowledge. And the Bayesian method, sometimes we don't think to the Bayesian method, and I can show you that sometimes it's very important to introduce this a priori. We have uncertainty of calculation, forecast interval. So, and I write this slide from a moment, but now we have to take in account all the problem which I speak a few minutes ago. Also some methods, stat model, adaptative Kalman model. We think that the Kalman model is very efficient to be adaptive. Another way to be adaptive is not on the parameter, but on the weight of a mixture of predictor, mixture of experts. Some people say aggregation. So several predictors are used in parallel. The optimal weighting in the mixture used for producing the final forecast is calculated by different algorithms. Now we have some result. We are relatively happy of this method, and in the mixture we can introduce some very adapted predictor, adapted to degradation of the consumption, to a crisis, for example, to the part important of renewable. It's very easy to use a lot of predictor like this. Gamma additive generalized model, my colleague will point, and we try to functional models. Load curve is divided into functions. These functions are projected in a wavelet basis. Similitudes between level of decomposition are used for forecasting function. We think that the decomposition in a wavelet basic, the similarity calculated in a wavelet basis is more efficient because we are able to take in account the high frequency and the low frequency. 2 minutes? I thought it was 45. So kernel wavelet. We're able to do clustering with wavelet, with the spectrum of the wavelet, a mixture of experts. Bayesian approach, we have short data, R is short data, B is big data. We use the information from A to B, we feature similarity, and we are able to introduce a priori. The result is good with RMSE go from 1,000 to 800. Problem of the management of uncertainty, because I think is the most important part of my presentation. We use residual, mixture of predictor, Bayesian method, KWF, and the more current usual method is residual. We use and we have a confidence interval from the prediction of KWF model. As a vector wise induce probability distribution, and we use this probability distribution for, I think, is a very efficient method. So I can speak later with you about that. And finally, I will show you some aspects of the future work. Future work, we have the change of the conception, would change, evolving in the use, heating pump, Stirling motor, battery, microgeneration. The problem of demand-response service, pilot hot water heater online, Electricté recharge, contracted interruption, the problem of the smart grid. What is it really about the smart grid? A lot of people speak of smart grid. What is the technical limitation? Local forecast, renewable. And for that, we have to use prospective method, parsimonious model, vectorial model, reduction dimension, factor model, clustering. We are working now on online clustering, multi-scale, mixed model, high dimension, reactive power forecast, non-stationary, locally non-stationary process, simulation of the use, mixture of expert with adapted expert. I think we are working on all this method, but I think it's perhaps not enough, because this method derived from stochastic process. I think I can, before the end of the week, I can learn from somebody here for new methods, for example. I don't know exactly, new mathematical methods that can solve the problem of the management of energy. And the problem of uncertainty too. So, finish for now. But, I thought I have 45 minutes. Yeah. Yes. Yes. But I have not to apologize because even it was 45, it's too long for a presentation. I have to apologize for my English, it's very difficult. I hope you understand some words.
Have we got any questions? Yes.
Well, yeah, okay. You were talking about the forecasting needs for the future.
Yes.
And one thing we've been asked in Denmark, which is quite funny, is to forecast the flexibility of the consumer. Because they want to have some demand response depending on the needs for, I don't know, accommodating the wind power forecaster or something else.
Yes.
So they want us to forecast how flexible are the consumers at different places and depending on the hour of the day or different things. Is it something that you're looking at?
Yeah, yes, it's completely that I look at. Yes.
Okay, because what you were saying is that you want to improve your forecast in view of the change of behavior, but you don't try to forecast how flexible the consumer is tomorrow at 2 p.m., for instance.
We have to do some simulation for that.
Okay.
For example, we are working with IBM Research. We build with a workload generator. We are able to simulate 35 million of smart meter. We are able to cluster all the smart meter in some cluster. Some people the heating pump, people have the electrical heating, and we simulate the response, demand response to, for example, an order to interrupt the individual consumption, and it's very. But we will simulate this thing. For us, it's very important, and I speak during my presentation of simulation of the use. Is that thing? After the answer in terms of forecast is more complex. But, for example, there is a problem because, for example, the national EDF provider will give an order of interruption for price reason, for example, and on the network, the local distributor have not the same needs. For example, he needs to use wind farmer, and it's possible to see how we can l'effacement en anglais, interruption, yes. You have to manage the different interruption. That is very, and the problem is that, as I say, we are not sure that the consumer will be very interested in changing his behavior. For example, in California, a lot of customers follow the rates, but other customers don't follow the rates because they don't care, they have enough money. And, I don't think, and about the smart grid, people say, oh, smart grid is only a problem of fashion. We are not able to manage interruption on individual consumer. It depends. In France, the current problem is that the smart meters are very expensive, and it's very difficult to, from a forecaster point of view, it will very well if we receive each 10 minutes all the information of the consumer, but it's a fact that it's not possible.
You mentioned that smart meters are in quite large number in France.
Yes.
But you still have smart grid as your future goal. Does it mean that they are randomly distributed among customers who just decide to buy them, and they are not installed in particular, let's say, districts or in some settlements? These smart meters, they are just randomly bought by customers, and they don't form some clusters geographically or purpose-built or something like this. How these smart meters exist in France in such a number? They just bought by people by their own will. Is that correct?
Yes.
Or there are some programs that implement them for particular towns, or do you have purpose programs in France to implement smart grids?
The smart meter is not a French decision, it's a European decision. In France, theoretically, we have to install 35 million of smart meters in 2016, I think. And
So it's target, it's not existing yet.
Currently, there is only 300,000 smart meter installed in France. But the rule, everybody, every customer has to have a smart meter in his house. He has not to buy, he is obliged to buy, to pay tax for that. And evidently, I don't, after that, there is some concentrator or source meter. And it's possible to measure the consumption at this level. That we will do is to constitute some cluster of smart meter of clients to be able to improve the forecast and to understand the behavior of the customer.
That is still something as a target in future. You don't implement it at the current stage.
Implement in the future, please?
At the current stage, they are not implemented, this clusters of smart meters.
Yes, but there is a smart meter, there is a physical concentrator, but there is a lot of, I don't know how it's possible. Sorry, here there is a lot of smart meters, there is a host of transformer. There is a lot of, it's possible to, it's not interesting to have all the customer, it's possible to have a concentrator of a customer, it's important for the measure, but there is a different level of measure, there is the different level of transformer, but we simulate the aggregation of a smart meter on the network physically, but we simulate too the aggregation of smart meters by use. For example, we will together the smart meter of clients, customers, they use electrical pump, they use cell, fuel cell, for example, is a new
Do we have any more questions?
So how are consumers motivated to be flexible? Is it just tariffs? And you say you have to forecast flexibility.
I cannot answer currently this question because I hope that the number of customers that can be flexible. I don't know, the individual customer, it's for example, there is the residential, the individual customer currently now the most part of the customer are to contract, and for the hours the rate is not the same, and we will experiment over behaviors of the customer. So for the flexibility, we have only simulation now. We have not. There is a problem between the different offers. Again, there is a financial direction, there is a technical direction, and there is not. There is not coordination. Mr. Smercy.
I think historically in France is the time of use system that's permitted to, and then flexibility. So if they continue in the same direction, that would be real-time pricing.
Yes. But the number of the customer potentially, I don't know currently. I think almost individual customer.
Did I hear correctly that real-time pricing is being considered? Is that true? Or I thought I heard somewhere that real-time pricing is considered in Europe for this.
In
real-time
France,
pricing.
no.
Was
It's not
it
used in France. It's used in California.
Yeah.
And it's currently in Denmark. We are moving to that. Some companies, like my provider, for instance, sent me a letter. I don't know, a month and a half ago, saying real-time pricing. It's here and now. Do you want to sign up for it? So it's not spread. It's more on a voluntary basis. But it's been proposed in several places. I don't think Denmark is the only one. I just can't talk. No, I was saying for the French context, the next step would be real-time pricing. But I don't think it's been considered yet. Even.
What's the take up been like in Denmark then for that sort of offer?
Sorry, what's
Has there been a big take up?
what would you mean by take?
Well, people signing up for real time.
No, that's. I mean, we can discuss that very at length because I mean, there's the consumer behavior is, I'd say, is that you don't want to move into the unknown. There's no guarantee with what you would get with real-time pricing as of now. So it's a bit difficult to tell people you have to sign up for real-time pricing, but we cannot tell you what it's going to be.
Where's the benefit?
There's no. But for the utilities, for the operators, there are benefits because they know they could have new flexibility. For the customer, there's none. I mean, there's no contract that can bound prices. There's no guarantee of a mean price over the year. There's nothing. It's just somehow signing a check to the devil. So far.
That's why, actually, I should say, that's why I brought it up, because I mean the great success stories in the U.S. have been contracts where they give, there's one example, you know, in New Jersey they give a $50 Walmart coupon and a small rate reduction, and they get a small amount of flexibility, you know, and so both sides get a certainty in their service, you know, and there's a risk on the utility side because they've engaged in a contract for maybe a few years. You know, but at least, you know, it's a way, you know, these contracts can be balanced to deal with that risk, and that way the utility company has control. They can ramp up and down the appliance by say 20% up and down without affecting the quality of the homeowner. So,
EDF is a very big company. It's very heavy to take some decision.
yeah.
There is new competition. There is a problem of European rules.
Okay.
It's not easy to evolve very easily.
Right. Well, if we thank Xavier.